One of the ideas we're going to explore in this section is the slope of a line. And the slope of a line is a measure. It's a number that tells us how steep the line is. So for example, suppose we have this line here. If we put ourselves any point on this line, say we just place ourselves right here, I'll just pick any point. Now, if we were to move horizontally, say this distance right here, to get back on the line, we would have to go up this distance here. Now this vertical distance, this is called the rise, and this horizontal distance, that's called the run. And the slope, we're going to define to equal the rise over the run. Now here's another line that goes through that same point, but I'll make it steeper, a lot steeper. Now in this case, the run is going to be the same, but you see what the rise is? The rise is much bigger. So what happens is that the numerator in the red line is much bigger than it is in the blue line. So the slope is going to be bigger. It'll be a bigger number. The bigger the number, the more steep the line. Now just to start, what we're going to do is, in problem number 1, we're given that the rise of a line is 4 and the run is 2. So suppose we're somewhere on the line. This says we would run 2, rise 4, and that would put us back on the line. So the slope here is going to be the rise over the run. Now the letter we use for slope is a lowercase m. So m is equal to the rise, which is 4, over the run, which is 2. So the slope here is 2. And just to get a feel for what's going on here, I mean, that's our answer. But to get a feel for what's happening, we could write this, 2 over 1. And here's what this means. You know, this is the rise. This is the run. So what it says is that for any point on the line, if we make a run of 2, now it's positive, so I'll go to the right. If this is 1, I would go up 2, and I'm back on the line. If I go over 1, I go up 2, I'm back on the line. Now let's talk about a formula for a slope here. Suppose that we have a line in the coordinate plane that maybe looks like this, and there's 2 points here. There's this point here and this point here, say. Now this point here has an x value, let's call it the first x, and a y value, let's call it the first y. So there's an ordered pair here, x1, comma, y1. Same for this point, it has an ordered pair. Let's say this is at x2 for the second x, and y2 for the second y. So when you see subscripts like this, the subscript is just a name for this one. It's like, okay, this is the first x, the second x, the first y, the second y. Now what I want to do is get a formula that measures this rise over run, right? That's the slope down over here on the left, the rise over the run. So I'll do the run first. Suppose we're at this left point and we make a run of this much. Okay, so how far is that? Well, you can get this. If this was, say, 10 and this was 3, what would that be? How far would you go from, if you're at 3, to get out to 10? Well, you're thinking, well, 10 minus 3. Okay, but in general, it's going to be x2 minus x1, right? If it was 3 and 10, you take the second x minus the first x. But in our picture here, that's going to be, this distance right here is going to be x2 minus x1. And then likewise, the rise is going to be the second y minus the first y. Does that make sense? Like, you know, what if this was 8 and this was 5? You're going from 5 to 8, so you went up by how much? Well, 8 minus 5, the second minus the first, right? Second minus first. So now, if we say that the slope is the rise over the run, we're going to have, in terms of variables, the rise is the y2 minus y1, and the run is the x2 minus x1, and there's our formula for the slope given 2 points. What it says to do is to get the slope, we're going to make a division. In the denominator, I'm going to put the second x minus the first x. In the numerator, the second y minus the first y. Let's try some. So let's see if we can find the slope between these 2 points here. So we know, we got a formula, so let's always start with our formula. It's like a road map. We'll get y2 minus y1 over x2 minus x1 So the formula tells us to take the second y, subtract the first y. Now, I'm just going to read left to right. If you read right to left, we'll get the same thing at the end, but our computations in the middle will look different. But I'm just going to do it like this. I'm going to go left to right. So here's what I see. This is the first x. That's the first y. This is the second x. That's the second y. So when I compute, I will get m equals, okay, now it's the second y minus the first y. Second y minus the first y. That's going to be negative 10 minus 9 over, right? Okay, second x minus first x. I come up here, here's the second x, here's the first x, right? If I'm looking left to right, there's the first x I see, there's the second. So second minus first is going to look like this, 6 minus 1. So we are going to get a slope of negative 19 over 5. And what this means, just so we get a feel for it, is for at some point on the line, say that's some point on the line, here's what we would do to get back on the line. The horizontal change, the run, is 5, so we would go over 5 units to the right. So we're going to go 5 to the right. And then to get back on the line, the run, the rise is negative 19, so that's going to go down 19 units. So we'll go to the right 5, down 19, and that'll put us back on the line. We want to find the slope of the line that passes through these 2 points. Now we just have to be careful here because we got all these negatives, right? Look at all these negatives. So when we put these numbers into our formula and compute, we just got to be a little bit careful. So I'm going to start here by writing the formula. M is equal to y2 minus y1, second y minus first y, over x2 minus x1. Now let's compute. So m is equal to, now, second y minus first y. Here's the first y, here's the second y. So what we're looking at here is second minus first. So how about negative 20 minus negative 16? Right there's all those negatives. And then the denominator is the second x minus the first x. Well, here's the first x, here's the second x. So what we're going to get is the second minus the first. So we're going to get negative 12 minus negative 10. Right? Does that work? Second minus first. Negative 12 minus negative 10. Now, this will give us, just computing now, that we've got m equals, okay, negative 12 plus 16 over negative 12 plus 10. So m is negative 4 over negative 2. So m is 2. I got a slope of 2. So they're not asking us for us in this case, but just so we know that the slope's always a fraction, so I'm going to write it as a fraction. Write any number as a fraction, just writing it over 1. So 2 is 2 over 1, and what that tells us is that if we're any point on the line, we make a run of 1, right? That's from this one right here, positive, so we go to the right one. We would have to get back on the line by going up 2. So I would go up 2. Over 1, up 2. Over 1, up 2. Here's 2 points. Let's see if we can find the slope of the line that passes through them. I'll start by writing this formula for the slope. So y2 minus y1 over x2 minus x1. So we will get m equals, okay, now the second y minus the first y. Careful with the negatives. Negative 5 minus negative 4 over the second x minus the first. 7 minus 7. That looks like it's going to give us a problem. Let's go on. In the top, we'll have negative 5 plus 4, but in the bottom, we'll get 0. So here's what we end up with. We end up with negative 1 over 0. Now, this is a non-zero number over 0. This is undefined. So we're going to say that, in this case, the slope is undefined. Now, if we were to graph these 2 points, look what would happen here. What do we do here up in the top? We go to the right 7, down 4. So if we just kind of imagine that, we go to the, here's our coordinate system. We go to the right 7, down 4. And then the next one, we go to the right 7, down 5. Okay, pass a line through those. That's a vertical line. So these lines, vertical lines, have undefined slope. Not just this one, but all vertical lines have a slope that's undefined. Let's find the slope of the line passing through these 2 points. So I'm going to start with a formula. M equals this fraction, y2 minus y1 over x2 minus x1. This will give us that m is equal to second y minus first y. Negative 2 minus negative 2, right? Be careful with the negatives. Negative 2 minus negative 2 over negative 6 minus 5. How about m equals negative 2 plus 2, oh, I see a 0 there, over negative 11. So m is equal to 0 over negative 11. Now, this is just the opposite case of what we had over here in number 4. In number 4, we had non-zero divided by 0, 0 on the bottom. That makes it undefined. Now we've got 0 on the top divided by non-zero. So I've got 0 on the top. This is defined, and in fact, it's equal to 0. So that's equal to 0. So the slope here is 0. Now, to get a feel for what's happening here, I'm going to write that as a fraction, right? Any number is a fraction if you write it over 1. And what this tells us is that if we're on, let's just draw some line here. Maybe what we do is we're on the line someplace. What kind of changes do we make? Well, in this case, the run is 1, so we would come to the right 1, and then the rise is 0, so we make no vertical change. So what we get is just this. Now that's a horizontal line. So all horizontal lines have 0 slope. All vertical lines have undefined slope. Any kind of a slanted line is going to have a non-zero number. To construct this graph, notice this, that the x's and y's are on one side and the constants on the other, and the coefficients here, these multipliers, both divide evenly into the 4. So this is a good time to use what's called the intercept method. And here's what we do. We just need 2 points to get a line, so I'm going to write x and y, and the values that I'm going to choose here are these. I'm going to choose x to be 0. I'll put a little star there to remind myself that's the one I chose. And if you put 0 in here, what do you get? It's 0, easy to compute with. And then you're left with 0, that's gone. Negative 2y equals 4. Negative 2y equals 4. So divide by negative 2. 4 divided by negative 2 is negative 2. Now choose y to be 0. If y is 0, put 0 in for y, that whole term is gone, right? Negative 2 times 0 is 0, and you get x equals 4. Easy to get those 2 points. Then to construct the graph, we'll just plot these 2 points. 0, negative 2 is here, and 4, 0, that's over here. And now we'll do our best to draw a line through these 2 points. I'm using a straight edge on this one. And there's our graph. Just remember what the graph tells us now. It says that if we pick any point on the line, I'm just going to pick one like this one. That's got an x value and a y value. And if I pick this x, put it back into here, and this y, and put it back into here and compute, I'm going to get 4. That's true of every point on the line. The line is a picture of the solutions to this equation. Let's give this one a try in number 7. Now I'm going to use the intercept method just like we did in number 6, because the x's and y's I have on one side and the constant on the other, and I notice that these multipliers, those coefficients, both divide evenly into the 24. No fractions. Let's set up a table and we just need 2 points. So I'm going to choose x to be 0 because it's easy to compute with. And then if you put 0 back in here, 6 times 0 is 0. That term is gone, and we're left with 4y equals 24. So divide by 4. 24 divided by 4 is a 6. And now choose y to be 0. If y is 0, You put that 0 in here. 4 times 0 is 0. That's the whole point of choosing the zeros. The terms just go out. And you get 6x is 24. 6 into 24 is 4. There's 2 points. Let's plot them and we'll get our graph. So the first point, 0, 6, is up here. And the second point, 4, 0, that's over here. Let's pass a line through these. I got my straight edge, and I'll just draw a line through those 2 points, put some arrows on them, and there's our graph. Let's take a look at what's called the slope-intercept form of a line. That's this one right here. It's going to be written like this. Y equals mx, now you know what m is, this is slope, plus b. Now in this case, when you see an equation like this, m is the slope, and b is the y-intercept. This is the point on the y-axis at which the line intercepts the y-axis. The line goes right through that number on the y-axis. So just for example, what if we have something like this? Y equals negative 2/3 x plus 5. That negative 2/3 is the slope. That's b, that's the y-intercept. Let's get the graph. So we know that this is the y-intercept right here. So it crosses the y-axis at 5. So I come to my coordinate system, I put a point at 5 on the y-axis. Now I need just one more point, and the point that I'm going to get, I'm going to use the slope to get it, right? The slope is the rise over the run. So look what we have here. I'm going to start at this point right here, and I'm going to make these changes. Now I always do the bottom first. It doesn't matter what order, I just use the bottom first. This is a positive 3, that's the horizontal, right? That's the run. So I'm going to come over 3, and then the top says drop by 2. So I'm going to do this. I'm going to go over 3, down 2, and then put another point. So there's 2 points on this line. And as best we can, we'll pass a line through those 2 points. Now this problem here, number 8, is y equals 3/5 x. It's almost like this, right? It's almost mx plus b, but there's a b missing. Well, what it really is this. 3/5 x plus, if the number's missing, it must be a 0 because we just don't write zeros. So here's the slope. Here's the b, that's the y-intercept. It goes through 0, goes right through the origin. So let's construct the graph. So this line passes through 0, so it's going to go right through the origin. And then look at the slope here, 3/5. So the bottom is the horizontal. That's the run. I'm going to go over 5 and up 3. So let's make those changes. We're going to start here at the y-intercept, which is 0. Then we're going to go 5 to the right and then up 3. Now this is not part of the graph, right? I'm just drawing that so I can see where I am. And then I've got another point. And I'll pass a line through these 2 points with my straight edge. And there's the graph of that line. Now in this problem here, y equals negative 6x plus 8. There's the slope, but I'm going to write it like this. Negative 6 over 1, right, because the slope's a fraction. And here is our y-intercept. So the line crosses at 8. Let's get a graph. So the line crosses up here at 8, and it has slope negative 6. So what we're going to do is, right, we're going to go to the right 1, then down 6. So I'm going to draw it on here. It's not part of the graph, remember. I'm just seeing where I am. To the right 1, down 6. Looks like it's right there. This is a very steep line. Yeah, very steep. Okay. We've got it. Y equals 8x minus 4. So here's our slope, right? The slope is 8, which is really 8 over 1. And it crosses here at negative 4. Let's get a picture. And then trying to pass a line through these 2 points. I think we're going to get something like that. Pretty steep line. There we go. Now, in this equation, the variables are on one side and the constant on the other. So I might be thinking I'll try the intercept form, right, where I get a little table and choose zeros. But the problem here is that the 3 and the 4 both of these do not divide evenly into the 3. So I don't want to use this method. What I'm going to do, rather than the intercept method, is I'm going to solve for y and use the y-intercept form, slope-intercept form. So let's solve for y. So what we're going to do is we're going to subtract 4x, so we'll get this. 3y is equal to negative 4x plus 3, right? I just subtracted the 4x from each side. And now I'm going to divide every single term by 3. So dividing each term by 3, we'll get y equals negative 4 over 3x plus 3 over 3 is just a 1. So here's our slope. There's our y-intercept. So we can get the graph. So this line crosses at 1, and it has slope negative 4 over 3. So we know what we're going to do here. We're going to go, not going to draw the red this time. We're going to go to the right 3 and down 4. Right, so to the right 3 and negative, so down 4. So let's do that. So I'm going to go to the right 3, down 4, 1, 2, 3, 4, puts us here. And passing a line with my straight edge through those 2 points gives us this line.